Hello everyone. In this worksheet, we are going to work on section 8.1, which is about coordinate system. As you see in the first example or problem, we are going to find the projections of the point on the xy, yz, and xz plane. And we are supposed to draw a rectangle box using these points. And we are going to use the x value, the y value, and the z value. First of all, the projection of this point to xy plane is the same as keeping x and y values and putting 0 for z value. So for the projection on the xy plane, that would be 2, 3, and 0. For YZ plane, it is keeping Y and Z, which are 3 and 5, and 0 as X. And also the projection on XZ plane would be 2, 0, and 5. Using these projections and using the point 2, 3, and 5, and of course with the origin, we are going to draw that. So if you follow the points, you would see that the projection cube or box will be something like this. As you see, when this is the point here, the given point, and the projection on xy plane, which is this part, is 2, 3, 0. And the projection on yz plane, this is y and this is z, so yz plane will be this one, back of this cube. Or maybe I can draw it like this. And this part as dotted lines. So that would be 0, 3, and 5. Also, the projection on xz plane will be this part and also these, and this includes the other parts. XZ plane means all x-axis, all parts of that, and also all parts of z-axis. So the positive part, the negative part. And you can see that this is the point for that. Next part says label our vertices, as you can see here, and find the length of the diagonal the box. So what does that mean? The length of the diagonal of the box. Let me clear all these. So the diagonal here is the distance between the origin, which is 0, 0, and 0, and the point that is given to us, which is 2, 3, and 5. So this distance from here all the way to here, let's say the point is P, O is the origin, so OP, and the distance of that will be the square root of the distance between x values, which is 2 minus 0 squared. Distance of y values, which is 3 minus 0 squared, and distance between z values, which is 5 minus 0 squared. So it will be square root of 4 plus 9 plus 25, which is 38, which is approximately 6.16. We don't have any units here, but let's say it is centimeter, so you can put centimeter here. Let's move on to the next one. For this one, part A says, what does the equation x equals 4 represent in R2. It means you only have x-axis and y-axis. So this will be in R2. X values, y values. We have a plane, two-dimensional plane. And since we know that x is 4, it means that you would apply all y's here. So the reason that you have this line here, it means is for all points that you can pick from this line, x value would be 4 and you would have different values for y. So this is the graph related to x equals 4 in R2. But when we want to draw it in R3, that would be different. So in R3, we would say x is 4, but we have all values of y and all values of z. So it will be a plane because you have x equals 4 as a fixed number or value, but these two change. So you would have a plane here. That would be a plane standing on x equals 4, which you see here, and it covers values of y values and z values. Part B, what does the equation y equals 3 represent in R3, which is the same as A, but in here we have y equals 3, so we would have all x values and all z values. So this one will be here, this plane that you see. It covers all z values, all x values. It is parallel. If you see, this is x-axis and this one is z-axis. So it is continued, to the negative parts of them. And the surface, which is kind of gray here, is parallel to xz plane. Okay, next part is what does y equals 3 and z equals 5 represent? It means that y is fixed, z is fixed, but we have all x values. So when x changes, y doesn't change, z doesn't change. It means that you have another surface here standing on z equals 5 and y equals 3. But it covers all x values. And the line that is here, you see here, is the intersection of these two planes. So if the question was, what is the intersection of these two planes? You would say y equals 3 and z equals 5. Okay, next one. It is question number 3, which says find the distance from 3, 7, -5 to each of the following. Based on the previous examples, you would say that I know the xy plane and I know what yz plane is, also z-axis. For the first one, when we want to find the distance between the point 3, 7 and -4, just imagine that point. Let me draw something like this here. So 3 units for x, if it is x, y, and z. 7 units parallel to y-axis. So 1, 2, 3, 4, 5, 6, 7. We start from x equals 3 and we move along y value. And from here, since z is -5, you're going 5 units down. So for z-axis, we have another part, which is the negative part. And along that, you're going down here 5 units down, which means -5. So this is the point that is given to us, 3, 7, and -5. So what is the distance between this point and xy plane, which is this surface? Of course, it is 5 units, or we can say the absolute value of -5, which is 5. For part B, it says the distance between the point that is given to us to YZ plane. So YZ plane is here. And the point that we have is here. So what is the distance? That would be 3 units. So for this one, the absolute value of 3, which is 3. The last one is not a plane. That is the z-axis. We know that where z-axis is here. And this is the point that we have. So the closest point to z-axis, the closest point to this point, the given point on the z-axis is the point that has z value but doesn't have x and y value. And we're going to find the distance between these 2 points in order to find the distance between the given point and z-axis, because we know that for finding the distance, we are going to find the measure or the distance of the line that is perpendicular. So how can we find the distance between these 2 points? That would be square root of the distance or the difference between x values squared, y values squared, and z values squared. Pay attention here, that is -5 minus -5, which is 0. They are the same. So the answer would be square root of 9 plus 49 plus 0, which is square root of 58, which is approximately 7.62. Okay, the next one, question number 4, says find an equation of the sphere with the center 2, -6, 4, and the radius 5. Describe its intersection with each of the coordinate planes. So first of all, if we want to find an equation of the sphere, as we have seen the formula for that in the lecture, you would write x minus x value of the point, which is 2 squared, plus y minus y value, which is here, squared, plus z minus 4, z value, equals the radius 5 squared. After simplification, we would have x minus 2 squared, y plus 6 squared, z minus 4 squared equals 25. Next part, describing its intersection with each of the coordinate planes. So first of all, if we want to find the intersection with xy plane, because this is one of the coordinate planes. So what does it mean? According to the previous examples, we know that when we want to find the intersection with xy plane, we would keep z value as 0. So we are going to set z equals 0. It means that you would have x minus 2 squared, y plus 6 squared, and 0 minus 4 squared equals 25. After simplification, we would have x minus 2 squared, y plus 6 squared equals 25 here, and 4 squared is 16, so 25 minus 16 would be 9. What does this equation say? Or what shape this equation is representing? It is representing a circle with the center 2 and -6, and the radius equals 3. So the intersection with xy plane is a circle with this information. Likewise for other planes. So let me write it here. The intersection with YZ plane means you would set x equals 0. If you do so, you would have 0 minus 2 squared, y plus 6 squared, and z minus 4 squared equals 25. The first one would be 4, so we would subtract both sides with 4, so you would have y equals 6 squared, z minus 4 squared, and 25 minus 4, which is 21. So the intersection with YZ plane would be again a circle with a center -6 and 4, and square root of 21 as the radius. Pay attention that this point is on YZ plane because this is the intersection. Okay, and the last one is the intersection with XZ plane. We know that we are going to set y equals 0, and we would have x minus 2 squared plus 0 plus 6 squared plus z minus 4 squared equals 25. That would be x minus 2 squared, z minus 4 squared, and 6 squared is 36. So you would have 25 minus 36, which is -11. Maybe we expected to have a circle here, but since two square values, which are supposed to be at least 0 or positive, cannot be added up and the result be negative number. So this is impossible. So what does it mean when the intersection is impossible? It means that the sphere that we were talking about, this one, that we have the formula, does not have any intersection with the XZ plane. Let's do number 5. Number 5 is saying that show that the equation represents a sphere and find its center and radius. It's all about algebra. We know how a sphere formula looks like. So for this one, we're going to make groups of x and groups of y and group of z's. And -17 goes to the right. So how can we find, or we can write it in form of the equation that we are expecting? Okay, the trick was you would write x plus half of this number here, which is 4, squared would be here, minus, this one will be always minus this 4 squared, which is 16. This is the trick when you want to find square of the given two expressions in order to write it as quadratic. Plus, so what about this one? Same trick, y minus half of 6, which is 3 squared, always minus here, and 3 squared would be 9. And the last one, same trick, z plus half of this number, which is 1 squared minus 1 squared, which is 1, equals negative 17. So there, if you want to know why we did this, let's do it in reverse. This part is not in the solution. I'm going to illustrate more. What is the answer of x plus 4 squared? That is x squared plus 2 times 4 times x, which is 8x, plus 4 squared, which is 16. Compare this and this. Which part is extra? 16 is extra, comparing these two. So we're going to subtract this number. This is why we say we always subtract. Because in here, 16 is extra. In here, 9 would be extra. And in here, 1 would be extra. Okay, let's go back to our solution. Okay, we are going to simplify. Keep square parts. And add 16, 9, 1 to both sides. And we have negative 17 here, so altogether that would be 9. The sphere that we have here has the center of negative 4, 3, and negative 1, and the radius as 3. Number 6, find an equation of a sphere if one of its diameters has endpoints 2, 1, 4, and 4, 3, 10. So we know what diameter mean. Okay, let's write here. We know that radius is half of diameter, and we know what diameter means. So in order to find the diameter, we are going to find the distance between these 2 points, because 2 points are the endpoints of the diameter. According to the formula, we are going to write 2 minus 4 squared, 1 minus 3 squared, and 4 minus 10 squared. That would be square root of 44. And the radius would be half of it, which will be 1 over 2 square root of 44. We know that this can be written as 4 times 11, and we can write it as square root of 4 square root of 11, which is 2 square root of 11. So in here, we can write it as 1/2 times 2 times square root of 11. So the radius would be square root of 11. Now we have the radius and we're going to find the center. So let's say this is a part of sphere. Of course, this is a circle, not a sphere, but it will be a cut of that. So if this is the center and these are the points that are given to us, let's say 2, 1, 4 and 4, 3, 10. This part is the diameter, which is square root of 44. Half of it, which is square root of 11, is the radius. And we are going to find the center, which is the midpoint. In order to find the midpoint, we are going to add these points up and divide by 2. So 2 plus 4 divided by 2. 1 plus 3 divided by 2, and 4 plus 10 divided by 2. That would be 6 divided by 2, which is 3, 4 divided by 2, which is 2, and 14 divided by 2, which is 7. Now, we have the center, we have the radius. We're going to write the equation of the sphere, which is x minus 3 squared, y minus 2 squared, and z minus 7 squared, which is equal to 11. Let's do number 7. It says describe in words the region of R cube represented by x squared plus y squared equals 4 and z equals -1. So because z is -1, the points in the region must lie in the horizontal plane. We know where z equals -1 is. So if this is the graph, this is the plane, z -1 will be a surface like this. All points in the region must lie in the horizontal plane. Okay, I'm not a good drawer, so maybe this one. Z equals -1. It's a plane. And also this part, which is a circle, it has all points that lie on the circle with radius 2 because the square root of 4 is 2 and center on the z-axis because we have the intersection. Okay, number 8, write inequalities to describe the solid cylinder that lies on or below the plane z equals 8. So on or below z equals 8, it means that all z that we have are on or below 8. Okay, like this. Next part says, and on or below or above the disk in the xy plane with the center, the origin, and the radius 2. So this is xy plane, this part here, with the center of origin and the radius 2. So all parts 2, maybe something like this. Read the question again. Write inequalities to describe the solid cylinder that lies on or below the plane z equals 8. That can be a surface like this. So it says on or below z equals 8. And the other part is on or above that circle. What is that circle? When it says origin and radius 2, it means x squared plus y squared is less than 4. Of course, these are two at least 0, so they are positive. And since the cylinder that we are talking about is between these two, z should be between 0 and 8.